Okay, after we learn something about the limit, we're going to do something new today. It's called a tangent line and it's a slope. First of all, tangent line. If you have a graph of a function, let's see, f of x, the graph looks like, I just made something up, okay? So here is a point on this graph. And this x, let me call that C. So then the y coordinate of this point should be f of C. So you're all okay with this? That's next one. Alright, now if this function f of x is defined or has the definition or its domain is at least a open interval contains this point C. Why I say open interval? Because I don't care about the end point of the interval. So the interval here, as long as the C is in that interval, so that's why I say open interval. I don't care about the closing part. So if C is in the interval, which is, or C is in the domain, and that is this domain is in the, this interval is in the domain, then we can find a tangent line. We can just put another point slightly more than that, okay? And then we can connect these two dots. I get a line, and I call this as a secant. This secant has nothing to do with the secant function, as we learned in like trigonometric functions. We have secant, which is 1 over cosine, but this one has nothing to do with it, because that just means cut. So see, I cut from here to here. All right, now when I put here this point, I call this a C plus delta x, and that is from C I move to the right by delta x this much. Therefore, this x coordinate is a C plus delta x, and of course, this y coordinate of this point will be f of C, actually C plus delta x. So that's C plus delta x, and the y coordinate is f of C plus delta x. Alright, now this is a 90-degree, it's a right triangle, and if you want to know how much is this, you can use Pythagorean theorem. However, we can also know, like, what is this? How much is this? That should be f of C plus delta x minus f of C. Isn't it? That's the difference between this y coordinate. And what about this difference? The difference between these two x coordinates should be just from C to C plus delta, so that it should be just delta. Alright, rise over run. Rise over run. We learned this a long time ago, that is a slope. Right? Okay, so that's the slope of this secant line. And then when this delta gets smaller and smaller and smaller, and this delta gets smaller and smaller, so you fixed this point, and you're going to move this point along this curve, gets closer and closer and closer to this point. What do you have? You're going to have something look like, isn't it? It's going to, because this is a tangent line, because it's really close, these 2 points are really close together. So, okay, are you ready? So the tangent line, the slope is m, and this m is tangent line of, not the secant line, of the tangent line. Should be limit delta y, the rise over run, that's the run, and this is the rise part. And when this delta x approaches to 0. Okay, so delta y over delta x, which is this part. This is delta y, and here's the delta x, rise over run, so we get the slope of this tangent line, okay? And when this delta x approach to 0, or you can say limit delta x approaches to 0, and the denominator is just delta x, and the numerator you can write f of C plus delta x minus f of c. Alright, now this is a very important concept, and we know that once we have the function itself, and if I give you c, first time we're going to confirm that c is in a interval, open interval, that f is defined, then you can do this and you get the slope of the tangent line. Alright, so I want to give you one example and then you're going to see how did I do that. I have f of x equals 2x squared plus 3. Can you find the, I'll give you c equals 2. Can you find the slope of the tangent line that will, the tangent line of this function when c equals 2? Okay, we just need to plug in, and then we have this function. If you know that the parent function is y equals x squared, and then you're going to stretch it vertically by a factor of 2, and then shift up by 3. So the graph should look like this. It should look like this. And then when x equals 2, or when c is 2 here, for 2 squared, which is a 4 times 2 is 8, and so that is, there's a point here, it's 211. I couldn't draw it, but you know there's a point there at 211. So we're looking for the slope of the tangent line at that point. Alright, by the definition, we know m equals limit delta x approach to 0. I can just use this directly. So the numerator is f, so far we have c is 2, so it's 2 plus delta x, okay, minus f of 2, because c is 2, and over delta x. I want you to compare these two to see they're the same, right? So the only thing I did is I put a c as 2. Okay. And the next step, because I know f of x, so I know what is f of 2, and I know what is f of this thing. So let me just expand that. It's going to be limit delta x approach to 0, and then see what's on top. F of x should be 2x squared plus 3. So f of independent variable will be twice of the independent variable square plus 3. So f of this independent variable is going to be this 2 plus delta x squared times 2 plus 3. So this part is this f of 2 plus delta x. Okay? And then I'm going to minus f of 2. I just put that in bracket 2. So f of 2 is going to be 2 times 2 squared plus 3. I actually already know that is 11. And then divided by delta x. Now you see from here, from this to here, that's the definition, or we already know the definition, this. And then next I just use what I learned in pre-calculus about everything I know about function. Okay, limit delta x approach to 0. I'm going to expand to the top. So 2 plus delta x squared. You can use, you can do 2 plus delta x times 2 plus delta x, and then you do FOIL, first times first, outer times outer, inner times inner, and last times last, and combine it. Or you can use the formula to get the answer. The formula, I just write it very small here. If you know that, then you can use it. If you don't use FOIL, that's okay. So that's a squared plus 2ab plus b squared. If you expand that, you should get it. So let me just make sure that I have 2 plus delta x squared. I have this square thing worked out. So that's going to be 4 plus 4 delta x plus delta x squared. Okay, so I'm going to put that in the parentheses. So that's going to be 4 plus 4 delta x plus delta x squared plus 3. Okay, and then this I already know that's 11. So divided by delta x. Limit delta x approaches to 0. Okay, now the top we only need to distribute this. So 2 times 4, which is 8, plus 8 delta x plus 2 delta x squared plus 3 minus 11 over square root of x. Alright, now 8 plus 3 minus 11, so the constant will be gone because we have to combine the like terms, right? And then all the others, the other two, they're not like terms. The constant will be gone, and this 8 delta x over delta x, so I get limit delta x approach to 0, 8 delta x over delta x should be 8, right? And then, okay, 2 delta x squared divided by delta x, I should only have 2 delta x. Because that 1 delta x cancel that out from numerator and denominator. Now, once we have this, and we think this is interesting because when delta x equals approach to 0, as we learned earlier in previous sections, this part is approaching to 0. Multiplied by 2, again approach to 0 and plus 8. So that answer is 8. Are you happy? See, we get the slope. We get the slope at this point is 8. And at what point? At 2, 11. Okay. So if I ask you, if I give you the slope is 8 and the point is 2, 11, can you find me the equation of that tangent line? It's a quick review. It's not really in this calculus class. It should be in pre-calculus. So we're going to use the point slope formula, right? Which is y minus y1 equals m times x minus x1. And in our example here, this m is 8, and my x1 is 2, y1 is 11. Okay, so y minus 11 equals 8x minus 16. I add 11 on both sides, so I get a y equals 8x minus 5. I got the equation of the tangent line. I not only know the slope, but since we know the point, so we can also get the equation of the tangent line. All right, now let's do a quick review here. I give you a function, I give it that c, and I ask you to help me to find the slope of the tangent line, and then you just get m equals by the definition, which is rise over run, right? Slope is rise over run, but the run is approaching to 0, so that's the case here. At a given point, see, at a given c value, I give you 1 point in that interval, open interval. All right, now let me ask you another question. What about if I give you c equals 5? Can you do that? It's going to be very similar, right? Every single step should be very similar. I assume that you know how to do it. What about if I just say for any point? So I give you f of x equals 2x squared plus 3. Okay, I didn't give you that c. I just ask you, can you find the slope of at a slope of the tangent line at a function? I didn't tell you which at a value. I didn't tell you c is. So you get something like this. The slope equals limit delta x approach to 0 f of, I just put x plus delta x. Okay, this x later I can replace it by any value, and a minus f of the x. See, that's a run, right? That's a change in the y-axis, and then the denominator will be just x, rise over run. Alright, I'm going to continue. Limit delta x approach to 0. F of something is twice of that thing squared. So it's twice of x plus delta x squared minus and f of x here and over delta x. And next I'm going to replace. Sorry, I forgot. Plus 3. Let me just do that. I'm sorry. Minus, then I replace this as 2x squared. So, I think sometimes I want to skip steps. Okay, so limit delta x approach to 0. X. And then if you remember the numerator, we have like a plus b squared, which is a squared plus 2ab plus b squared. So I get a twice of x squared plus 2x delta x plus delta x squared, 2x delta x squared, twice of this plus 3 minus 2x squared minus 3. Okay, because I distribute this negative into the parentheses. The next one, limit x approach to 0, and then I distribute this 2 here. 2x squared plus 4x delta x plus 2 delta x squared plus 3 minus 2x squared minus 3. Okay, are you tired? There are too many things, right? Okay, so did you notice that I will cross out this with this? And also I cross out this 3 with this constant negative 3. Okay, so all those square terms and all those things are gone. I have only 2 terms left in the denominator. And if I divide it by delta x, what do I have? This 4x delta x over delta x, I get a 4x. Okay. And the second term, 2 delta x squared, which is this right? 2 delta x squared divided by delta x, I get a plus 2 delta x. Now what happened when delta x approaches to 0? This part approaches to 0, and then I will have only 4x. Oh, I find the slope of that function at whatever given point. So for example, we said what happened when c equals 2. Then we just plug 2 here, I got 8. Sounds good, isn't it? Yeah? Okay, so this thing have a definition called derivative. That means it's not only for particular c, it's not like the one we had earlier for a particular c, and then to get the slope. But this one, if I more generally for just x, I get this one. This has a very, very special name. It's called derivative of a function. Alright, so this is a little, I think this is a big step. You are stepping into the real calculus, okay, to find the derivative. And this is the definition of the derivative. Okay, so that's it. I think that's it for this session, and then I'm going to talk about more about the derivative.